Hey you, welcome back to your channel on J Physics Maniac. So this is the second video we are starting on the blackbody radiation. So today we'll see the derivation of Rayleigh-Jean's law. So let us have a quick recap of whatever we have studied in the last lecture. So the first thing that we have seen that in case of blackbody radiation, that according to classical electromagnetic theory, if we talk about classical EM theory, so what is that? That oscillating charge particle, oscillating Q will emit radiation, right? This is the first thing we have observed. Second thing we have observed, according to Stephen's law, the radiant power P, that is proportional to T to the power 4. That means any hot body whichever has temperature will give some kind of radiation, and radiant power will be proportional to T to the power 4. And third one, in case of cavity radiation, when we talk about Ferri's black body, so there the entire cavity does not act as black body only. The small opening acts as black body. This is very significant. So please remember these points. Now let us proceed with the derivation of Rayleigh-Jean's law. We will see the classical approach. We will use some geometrical things. So please watch out. So what is happening here? So we are taking this enclosure over here. So we are talking about this enclosure. It's a metal enclosure. It is at some temperature. So because since it is at some temperature, so it will start giving some kind of radiation. So now we will be thinking that the radiations are reaching from this wall over here to the back wall, right? So the kind of wave it is generating is confined between this, and it will move from this side of the surface to that side of the surface. Now, interesting fun fact about metal surface is, this is a very important point, for a metal surface, the electric field becomes zero. So a little bit of quick knowledge from the waves and oscillation. So when a wave is represented, if we write y is equal to a sine of omega t minus kx, if it is a general expression of a wave, then whenever amplitude is equal to 0, we call those points as nodes. So if you check quickly, if I quickly draw a progressive wave like this, and this is the progressive wave we are denoting a sine function. So look at these points, this point, this point, this point. Here amplitude becomes 0. So these points are called nodes. Where amplitude becomes maximum, these points are called antinodes. This is common knowledge. You are well aware about this. So similarly, if we take the electric field, which is being generated over here, is a function of t and x, position and time, then there wherever E is 0, there the node will be created. So I can briefly say that on these surfaces, nodes will be created. Now, node will be created, that is fine. But if I want to check the surface, so let's say that this is one line we are taking, and if the wave is oscillating in a single loop, then this is node, this is node. By the way, we have taken this side to be A. The side of the enclosure is, it's a cubical enclosure, so side is A. So this length we are taking A. So when it is vibrating in a single loop, in one loop, then node to node distance is how much? Lambda by 2. So there lambda by 2 becomes equal to A. When it is oscillating in two loops like this, so there this will be node, this will be node, and this will be node. So there lambda by 2 plus lambda by 2. So in that case we will write 2 into lambda by 2 is equal to A. So in that way, if we escalate this up to n number of modes for n number of loops, we can write n into lambda by 2, that is equal to A. So little bit of calculation here. So n becomes 2A by lambda. Lambda if we can change, that is equal to C by nu. So it becomes 2A by C into nu. So this is the value of n. So number of modes of oscillation which is connected to the frequency. Now let us look at this equation. If we look at this equation, there is one more thing which you have to take consideration of, that since we are taking about this wall and this backside wall, so their electromagnetic wave will have two different mode of vibration. Like, since the wave is progressing along this line along y-axis, so either electric field can oscillate along z direction or the electric field can oscillate along x-axis, because we know that the velocity vector dot electric field vector, they are perpendicular to each other, their dot product will become zero. So since it has two different mode of vibration, so that is why this product will be multiplied by 2, and hence the result will be 4a by c into nu. Now if you place them along a line, so now we are trying to imagine what is the relationship between them. So I will plot it over here. Let us say number of mode is 1, 2, 3, like that it proceeds to n. So this distance over here, this much, if I talk about this length, it will become how much? It will become 4a by c into nu. With a slight increase, if I take this point as n plus dn, then obviously this length over here, this much, it will become 4a by c into nu plus d nu. So this gap which is pointed over here, it will give you the value of dn. This will give you the value of dn. So how much dn we are getting? dn we are getting 4a by c into d nu. So this is the simple calculation that, so the value of dn that we got, dn is equal to 4a by c into d nu. Now this is the calculation that we got by following the one-dimensional approach. Now the same approach I will escalate to three-dimensional cavity. So if I now talk about 3D cavity, for a 3D cavity we will have x, y and z axis. So if we proceed with x, y and z axis calculation, see first along x axis, let us check what will happen. So I will be using the same equation along x axis. What we can write, that I will write a is equal to nx into lambda x by 2, right? Now you see I am doing some kind of adjustment over here. So I am writing nx into, if I pull this down here, I am multiplying by pi, bottom also 2 pi. So there a is equal to nx. I will pull lambda x down, so I get pi 2 pi by lambda x. 2 pi by lambda x is the wave vector, so we get nx into pi by kx. So the value that we got along x-axis is equal to, a is equal to nx into pi by kx, where nx varies from where to where? It varies from 1, 2, 3, because it will only take the integral values. Similarly, along y-axis, a will be equal to ny pi by ky, where ny varies 1, 2, 3, same. And similarly along z-axis, a is equal to nz pi by kz. nz is equal to 1, 2, 3, exactly in the same way. Now very interesting thing, that if you square and add this equation, so here I am going to get nx square plus ny square plus nz square is equal to, how much you are getting? This factor will be a by pi whole square into kx square plus ky square plus kz square, right? So kx square plus ky square plus kz square, this particular value over here is nothing but, we know that is k square. So finally k square is equal to, k square into a by pi whole square is equal to nx square plus ny square plus nz square. Square root, it becomes k into a by pi, it becomes under root of nx square plus ny square plus of nz square. Substituting the value once again, so k is 2 pi by lambda, that is equal to a by pi under root of nx square plus ny square plus nz square. So please proceed with this calculation. Pi gets cancelled. 2a by lambda, lambda we can replace c by nu, c we are going to get the same value back, that is equal to 2a by c into nu. So eventually we reach up to this equation. Now that is very significant. If you look at this particular value, that is 2a by c into nu, what will happen here? Yeah. So this particular value shows that it is conforming a circle, because this is representing the equation of a circle where this particular quantity is acting as radius of the circle. In 3 dimension, this will represent a sphere. So now, if you look at this particular thing in diagram, the diagram will look like this. So look here, they are forming a grid kind of structure. As you can see, this is along x-axis, y-axis, z-axis. There are different values of nx, ny, nz are chosen, right? Which are varying from 1, 2, 3 up to infinity. And since they are uniformly distributed, so their density, the distribution of n is unity basically, because they are uniformly distributed. So any specific volume, they will give unit result, right? So now we can imagine, or from there we can calculate what is the volume dv. dv we can write 4 pi r square dr. So now carefully substitute 4 pi r is equal to how much? 2a by c into nu whole square. dr is equal to 2a by c into d nu. Correct? How much this is coming? This is 1632. So it is coming 32. Here it is into pi a by c whole square. This is cube, whole cube, nu square d nu. This is the result that we are getting. Now think, we are interested here only about one quadrant. We are thinking about only one quadrant. So how the quadrants are distributed? Here I have shown how the quadrants are distributed. Look at this particular diagram. So if you see one quadrant here basically is 1/8 of that. So here, since we are thinking about the first quadrant, so there I will divide that number by 8. So I will talk here dv is equal to, we will take 32 pi a by c whole cube nu square d nu into 1 by 8. So it becomes 4 pi a by c whole cube nu square into d nu. This is the calculation that we got, right? Now you can see here, this is a beautiful thing because it is conforming a sphere actually. We can take any value of nx, ny, nz, but the value will be so chosen in a way that this sphere will just elongate in that direction. For a specific value of nu, if you expand it to nu plus d nu, the sphere will only be elongated without destroying the shape of it. So this is the geometrical kind of thing we are following here. Now we want to calculate, finally, we want to get the number of modes. So number of modes will be n nu into d nu. N nu into d nu is equal to what? It is equal to density of the modes into volume element. What is the density here? Density is equal to 1, that I have already explained. Since the distribution is uniform, so density will be equal to 1. So that into 4 pi a by c whole cube nu square into d nu, right? Now you come to the energy part. Now here I am going to follow equipartition of energy principle. So if you think about equipartition of energy principle, we are going to compare that oscillating atom or the charge with a harmonic oscillator. For the harmonic oscillator, for one vibrational mode, there are 2 vibrational degree of freedom. Please be careful about that. One will come from the kinetic energy contribution, which is by virtue of momentum. Another will be contribution of potential energy contribution, which is by virtue of position. Per degree of freedom, how much energy is distributed? per DOF, for every DOF, how much energy will be given? Half kT. Since there are 2 degrees of freedom, so their energy for one mode will be 1 by 2 kT into 2. So that will become kT. This is a bit mathematical. Please be engaged. So finally, I am going to calculate the energy density. So if I calculate the energy density, U suffix T will become this number of mode, that is equal to 4 pi A by C whole cube nu square into d nu, that into kT. Now this is very important. Here finally, if you see this spectral energy density, it becomes proportional to nu square. What was our experimental observation? Please come and check. If we check our experimental observation, in the previous video we have already seen the graph looks like this. This is experimental observation. But when we are following the Rayleigh-Jeans law, this is ultimately the Rayleigh-Jeans law. Here Rayleigh-Jeans law is showing that this is proportional to nu square, which is parabolic in nature. That means as you gradually increase nu, it will start from here, will follow up to this, but after that it will keep on increasing in that. So this is what Rayleigh-Jeans equation is showing. There is a clear-cut conflict between the classical derivation and experimental observation, and this exact conflict is called ultraviolet catastrophe. In the next video, we will come up with how this ultraviolet catastrophe is resolved by means of quantum analysis. I hope you have enjoyed. Please go to the detailed mathematics, solve every single step. See you in the next video. If you like the video, please do like, share and subscribe. Thank you.